All right, so this is a quick catch-up lecture on seasons and navigating by the sun for people who are absent. You'll want to pause and fill out these notes if you were absent, and this is actually the second page that you will want to fill out. So I'm going to walk you through this real quick. Let's talk about longitude first, because that one's pretty simple. There's no natural point of reference for longitude, so unlike the equator, where 0 degrees latitude makes a lot of sense because we see a lot of patterns north and south, there's no real distinctive point of 0 for lines of longitude. So we made that up, and we put it at the prime meridian, which passes through England, or Greenwich, England, which is where we set our time to when we're calculating this. So this is 0 degrees longitude. 180 degrees away, you find the international date line, which means if you have 1 foot on each side of the international date line, you're experiencing different dates. So the date of here would be like November 15th, while it would be November 16th right across the line. Why did we put it in the middle of the ocean? Well, because if this line goes through countries, it makes things confusing if half your country is a day ahead. So this was a relatively good place to locate that international date line. So basically, if you wanted to look at, okay, who gets to celebrate New Year's Eve first, technically New Zealand is one of the bigger countries celebrating New Year's Eve first, and then an hour later, an hour later, an hour later, an hour later, an hour later. Why are each of these lines an hour? Well, because in 24 hours, the Earth will turn completely, and it'll turn 360 degrees. So 360 degrees divided by 24 hours gives you 15 degrees of longitude. So basically, we're going to calculate our position of longitude based on the noonday sun and the time that it is in England. So if it's noon in England and we are over here, let's just start, that's an easier one. We are right here. So we're 15 degrees away. We should be an hour behind them, because if we are west, we should always be behind them. The sun rises in the east, so it'll rise here first and then here an hour later. So we're an hour behind because, again, 1 hour because we're 15 degrees apart. And that's really all you have to do. So if you, basically what you're doing is, if you have no idea where you are, and let's say you look in the sky and at noon your sun is at wait a minute, so I'm confusing my latitude here for a second. If you look at if it's noon for you, the sun's directly ahead, but your watch says it's only your watch says it's actually 3 p.m. in England. That means England is ahead of you, so you must be behind, and because you're 3 hours behind them, you need to go 15, 15, and 15 degrees. So you would be 45 degrees west of them. And that's how you solve the longitude problems. Now, if you are ahead of England, you're going to be east all the way up until you get to the international date line, okay? Because that's when we start. This is no longer considered east. Now you're in the Western Hemisphere. All right, so that's longitude. For latitude, it's a little bit different. And remember, in these notes, we talked about the equator is where you would expect to see the sun 90 degrees overhead. Only on the equinox, though. This will shift on the summer solstice. It'll shift up to the Tropic of Cancer. On the winter solstice, for us, it'll shift to the Tropic of Capricorn. So, a couple things you want to do. Let's say the sun is no longer 90 degrees overhead, it's only 80 degrees overhead. That's a 10-degree difference, right? That means you've moved 10 degrees away from the equator. So I'll tell you how we determine north and south in a second, but you want to take the position of the sun in the sky and subtract it from 90 degrees to determine what latitude you're at. The second rule is, if when you look at the sun, because again, if it's not directly overhead, then it might be 10 degrees towards the south or 10 degrees towards the north. If the sun is 10 degrees, sorry, I don't mean 10 degrees, I mean 10 degrees away from 90. So if the sun is a little bit more in the southern sky, then you must be in the northern hemisphere. And if the sun is slightly in the northern sky, then you would have to be in the southern hemisphere. So this would make sense too. Let's say we're looking at the sun at noon and it only reaches 10 degrees above the horizon. Well, that doesn't mean you're at 10 degrees latitude. That means that you are 90 minus 10. You're at 80 degrees latitude. So if we go up 80 degrees, you know, we're above the Arctic Circle. And that makes sense because up near the poles, the sun is never directly overhead like it would be at the equator. And that's why seasons and temperatures never get very hot, because the solar radiation is not very extreme up at the poles. So one thing you have to do when you're dealing with latitude is you have to adjust for the tilt of the earth, because sometimes the sun's rays are directly overhead here, here, or here. So basically either your answer is going to be unchanged, or you're going to be adding 23.5 degrees or subtracting 23.5 to make up for that shift to the tropic. Now, of course, there could be a whole bunch of numbers in between, but the dates we're testing you on are only going to be on the equinox, on the summer solstice, or on the winter solstice. So that way you don't have to think of, sorry, winter solstice. You don't have to worry about the dates in between. So a general rule of thumb, if you see here, is that if it's the summer solstice and you're in the northern hemisphere, you're going to add 23 degrees. But if you're in the southern hemisphere, like let's say your positioning puts you here, and you know that the sun has shifted north, you have to add 23 degrees. So if you're down here, you might have to add 23 degrees. I'm sorry, you're adding 23 degrees north, but think about the way the numbers are running. Let's say you're at 30 degrees, you know the sun shifted north, you'll have to subtract 23 to get you to this number. You can also kind of do it with your hands. Say, okay, here I am, and I know the sun has shifted, so I need to move this up 23, and that tells me where I'm at. So, opposite is true if the sun has shifted south, which it does on our winter solstice in December. So if you're already in the southern hemisphere, you're going to add 23 degrees. But if you are in the northern hemisphere, say you're up here, and the sun has shifted that much, you have to move down 23 degrees, which is like subtracting it from 40. So that's how you determine latitude and longitude. And so hopefully that helps.